Hello, everyone. This is Sana. I'm working as a community initiative lead at Recro, and welcome to another Recro's webinar. So today we have a session on introduction to DevOps practices. And to tell you more about Recro, so Recro is a developer-focused organization wherein we are trying to connect developers' aspiration to the right opportunity by working with the high-growth startups like Udan, Swiggy, Dunzo, Curefit, and there are many others similar kind of companies we're working with. And today we have with us Jonathan Pereira. So Jonathan is working as a senior developers advocate at Progress Chef, and he has around 7+ years of industry experience working in the similar industry. And yeah, I think to tell about him more, like he would be the right person to tell you more about himself and about the topic also. Okay, so let's get on the platform. So today we are using AirMeet. And here I'll just tell you more about the platform, like how you guys can get the gist of it. So on the right hand side, you can see, I think, 4 sections there. So one would be the sessions. So in the today's session, as it's going to be on the beginner level, so we are having a welcome session which is going on right now. So I'm telling you more about the platform here, and then we will be having the presentation going on. It's more on the theoretical side, wherein you can understand how exactly the DevOps system works and how it's impacting the industry. And then you can see the attendees, wherein you can understand, like, you can get to know, like, who else is attending this session with you. And then you can see the chat option, wherein you can see 2 options there. One is live chat, which is going on right now wherein you're chatting, and the other one is the direct chat. And the fourth option is questions. So yeah, we will be having the last session. The last session would be the Q&A. So once we are done with the presentation, we will be having the Q&A round. So you can ask your question in the question section, and please avoid asking questions in the chat section. So, like, just to make it more elaborate here, we will be answering questions only which are coming in the question section, and it is because, like, we might miss out your questions if they are coming in the chat section, right? So please make sure you guys are asking all the questions in the question section. And on the downside, you can see a raise hand option. So just in case you guys saying, like, you can come on the platform, and if you have some doubts which you really cannot explain it in the in the text, right? So you guys can come online, and I can allow you the access, and then you can use it, and you can ask your questions or any doubt like if you have. So that's it about the platform. I'll just hand it over to you, Jonathan. You can sign off.
All right, thanks, Anna. Thanks for the quick introduction. I'll quickly, sorry about that. I assume you can see my screen.
Yeah.
All right, so let's get started. And thank you all for joining us today on this session on Introduction to DevOps. I hope this is going to be a very useful session. And my important goal for today is that you take away something which you can use later on in your journey or in your career. So quickly about me. Hi, I'm Jonathan Pereira. That's what I used to look like before the lockdown happened. And now I look the way you see me in the camera. Yeah, a lot of changes. It's been eight crazy months. Let's just all hope that all of this ends and we get back to the normal soon. So a little about me. I am a senior developer advocate at Progress Chef, which is a configuration management software, which also, by the way, is predominantly used in the DevOps process. And aside from this, I have earlier worked at companies like Postman and Automation Anywhere, which are by far one of the fast-growing startups based out of India. Also, I have been actively involved in open source communities, also a lot of other developer communities like your Google developer groups, the Facebook groups, and Mozilla Firefox groups. and been actively participating as well as contributing as much as I can. And finally, I also have helped a lot of companies to understand and adopt the entire DevOps practice. So as I'm sure many of y'all are also confused about DevOps, just like y'all, there were companies also facing similar problems. And the biggest question was, I think now it's no longer, that trend is quickly changing, but 3-4 years back, it was it was very difficult for a company just to understand the value of DevOps, and more importantly, get an understanding of why is it that they need to be seriously thinking about DevOps and their organization. So those are some of the things that I have done, and which is why I truly understand the challenges both developers as well as companies face when it comes to DevOps. And I do not necessarily have all the solutions, but I at least have some understanding that I can share with you, and that's exactly what today is going to be all about. So on the next, for the next 40-45 minutes, I hope to keep this short. I know many of you all have given up sacrificed your Saturday evening and come here, even though I know there is not much to do, but you could always be on Netflix, but you chose this. So kudos to that. I really appreciate that. And more importantly, I think I want to make this session a little more interactive. So if at any point in time you do not understand what I'm trying to say, or if you have any questions, like Sana mentioned, to the right there is your questions option. Just hit all your questions there. I'll try to answer them as and when I see them. Again, I might look a little distracted because I'm also trying to monitor the questions as they come in. Also, if at any point in time you are unable to hear me, unable to understand what I'm saying, or just are bored of listening to me, you can just type in like just shut up, or I can't hear you, something like that. Or you could just make sure that if you want me to shut up, just put it in all caps so that I know you're screaming. Ideally, I would love to hear you scream that, but unfortunately, I think this is the best we can. All right, so any questions so far? I hope not. If anything, like I said, question box to your right. Let's get started. So back in 2011, Mark Anderson from Anderson and Horowitz made a bold statement saying that software is eating the world. And this was back in the early 2010s, wherein we didn't really have that many softwares which were coming out. There were a couple of good ones coming out, but it wasn't that much. Make this statement back then made so much sense, and a decade later now, if you think back, this statement is growing exponentially and makes much more sense, because right now software is literally ruling the world. It's everywhere, right from the depths of the ocean right up to the International Space Station. Everything is being controlled and monitored using software. And in fact, a good example of how software is ruling the world is this right now. Air Meets, for example, is making something happen which otherwise would I think seamlessly be impossible. Like, think about 10 years back, if there was this pandemic, we would be scrambling for options to connect virtually, because back then I think we had web conferences tools like Cisco, which costed a lot and which weren't really easy to use. Zoom and all of these other tools have just come in, and they literally have changed the way we actually communicate. So imagine if the same thing had happened back then, and we wanted to do this session. We either could have done it in person, like a meetup, and wherein then you probably would have also got to scream at me in person. Not to forget, you also would have managed to get a cup of coffee. Now you need to make it yourself, unfortunately. But yeah, coming to how software has literally changed us. Like right now, it's giving us a platform wherein I am sitting in one place and I know there are people tuning in from various parts of India, I suppose, at the moment. But it's this visibility that literally makes it really nice. And more importantly, you do not even have to go through all the hurdles of actually getting up, dressing up, and coming to an event, bracing the traffic, and all of those problems. I'm pretty sure there are many of you who are quite underdressed for an event, and that's okay. No one's here judging, and I don't think anyone has their camera on except me. So yeah, and that's one of the reasons why I use a background. So yes, coming to the point, what I was making and how software is literally ruling everywhere, right? So before we actually understand anything about DevOps and everything else, we need to see that how software is actually made. And I'm sure many of you already know this because I'm assuming many of you all are already developers working in startups, enterprises, and your day-to-day function is creating software or some kind of code that usually gets translated into something like that. So at its core, you usually have three major teams. The first one is your software development team, wherein you have the developers like you and even I consider myself to be part of this team. If I weren't a developer advocate, I would be probably coding something in this team. And the thing about the software development team is this is the team which usually considers itself as the cool guys. And because after all, they are the ones who write the code, right? They are the ones who create the logic, build the code, and then build cool stuff. So it's no wonder that software engineers and developers specifically think that they are the coolest in the entire organization. It's sad that others do not think as much, but that's a topic for a different day. So the software development team pretty much creates the logic, codes, and then builds a software which can be released. This software piece, which by the way is right now just on the laptop or on the machine within the company, is then sent to the quality assurance team. So this is basically your testing engineers who then try to break your code apart and see what or try to find an opportunity to point fingers at you, saying that here you haven't done a good job, or you have messed up here, or there is a huge loophole here. Sometimes it also happens that they themselves are not curious enough and they let go of a lot of silly things, which is why you still see a lot of errors in production that customers then complain about. So do we blame the quality assurance team for this? Maybe not, because the quality assurance team is going to say that the developers built it, but the developers will then say that the quality assurance team didn't check it out. So fights like this start, but things like this escalate even more when the next team gets involved, and this is the system engineering team, also known as IT admin / IT operations team. So the basic goal of this, guys, is to take whatever application that you have built, which is on your laptop, and make it available to the world. Now, as easy as that may sound, there is a lot of work involved in this. And the cool software developers think that this is just a joke and they're just there, which is why one very common thing that I keep noticing when I talk to a lot of companies and I go and visit their campuses is that sometimes, actually many times, the system engineering team or the IT admin team is usually kept in a corner of the office, whereas the software developers and the QA teams would occupy the posh and the central areas in the office. Again, this is just an observation, but I'm just saying that's how IT admin folks are usually treated. So once they put it up on the server and it's available to the entire world to use or see, and then if something breaks, that's when all of the trouble starts, and then the whole blame game starts. So quickly to summarize this entire process, it's the developers code the software by creating some logic, putting in all the using a particular language framework, create a code, build it, and then it's handed over to your quality assurance team, also known as testers, who would then test it. They then hand it over to the operations team, who will then release it for the world to use. And sometimes, very rarely, you have another team which manages to operate, manages everything after the release. But in most cases, it is the system operations or the IT admin folks who take care of this part as well. So one thing that is clear at this point is that there are these walls which are in between each of these functions. And let's see how these walls actually create an issue. So this is what happens in real life. The dev builds something, hands it over to the operations, who then, yes, this is the exact problem. Now, the big problem here is when things go down and when things don't work as expected, the operations team will say that the software or the application that the developers built is faulty. But the developer is going to come back and say, hey, it worked on my machine, which is why this is one of the most common meme that software developers will see. So it worked on my machine, it's now an ops problem. And while this may be true or may not be true, the core to understand or that you really need to get a hang of is in their own places, the development team or your developer is also right in saying that the operations team may have messed it up. Because, for example, your developer may be working on a different kind of system configuration, and the operations team, when they were deploying it, might have deployed it on a completely different configuration. So it could be, in a way, the operations team fault. But at the same time, it could also be the developer's fault because the developer didn't really keep the configuration in mind or did not keep some kind of parameter in mind. So it really becomes difficult to know who is to be blamed, and yet you will have both the teams blaming each other all the time. So which is why there was this need to kind of simplify this matter. It wasn't so much as to identify who was to be blamed, but so much so as to kind of solve this problem that was happening, which is why the concept of DevOps came. So even before I delve into what DevOps is, I would quickly like to put a poll and try to understand how many people here have prior knowledge of DevOps or have used some kind of DevOps practices before or have even heard of DevOps. Let's take a quick poll. Also, in the meantime, while we have the poll going live, if, like I said, if there are any questions, feel free to let me know, ping me. You have the questions tab, which I'm monitoring. And also there is the chat box if you really need to use, if you do not want the entire world to know what exactly is going on in your mind. So yeah, either ways, whatever serves the purpose, that should work.
Okay, it always goes 50-50. 50% people said they are.
Wow. I could have just tossed a coin and got this result, but okay. So since we are stuck with a probability question, so I'll probably try to keep it equal for both. So let's then in that case first try to understand the core at what DevOps is. So in principle, if you see what a definition of DevOps is, it says that DevOps is just a set of practices that work to automate and integrate the processes between software development and IT teams so that they can build, test, and release software faster and more reliably. Now, that may look like a bunch of text just on that slide, and it If it throws you off, do not worry, I have you covered. This is what you should really be looking at. Just focus on the things that are highlighted, and that is all that you need to take out of this definition. So at its core, put simply, DevOps is a way to automate and integrate the processes which the software development team is using and the IT teams are using, so that you can build, test, and release software. As simple as that. So with this definition in mind, the existing process that we had, wherein the developers would code, create a build, and then hand it over to the testing team, which then hands it over to the operations team, now gets converted into something like this. Now, one key thing that you will notice here is this is a continuous loop, which is the core of the entire DevOps practice. Now, if you, like other people, also saw Dev and Ops bringing together and thought that DevOps is just about getting the developer and operations team together, you are not politically wrong, but it's technically not what DevOps actually is. So DevOps is not just getting together the development and operations teams together, but yes, in a way, it kind of ends up doing that. So in a DevOps environment, what you would be doing is everything right from your planning stage till when you're coding, testing, and even releasing. There would be equal weightage, like the 50-50 votes that you all just came up with. That's the kind of weightage both the development team and the operations team would have in every decision that goes in. So for example, there is a new release which is being planned. And even before the developers start coding, both the development team and the operations team would sit together and say, hey, this is what we intend to build, and this is how it will be released. So then the operations team can come in and say, then in that case, you probably might want to use this configuration, or this is the existing configuration that's already available, and this is what you should customize your code to deploy to. So all of these discussions happen right at the beginning in the plan stage itself, so that you do not have to wait till the end stage wherein the software is already released, and that's when you know something is broken. So which is when you then go back to your developers and say something is broken, fix it, and this entire loop continues. So similarly with the operations team, when they are deploying something, the developers are still equally involved. So if something goes wrong at any point in time, the developers can quickly say, okay, instead of doing this, you could just do this and get it quickly fixed. So there is this continuous synchronization which is happening between the developer team and the operations team, which is what the entire DevOps process is all about. So again, remember, DevOps is not a tool. It's not, in fact, there is no such position even as a DevOps engineer. But just for the sake of, let's not confuse that. But you'll see a lot of hiring happening in India as DevOps engineers. So no comments there. But anyways, so that process that we saw wherein there were continuous, where there were walls, now becomes a continuous loop, wherein first the developer creates code which is version controlled, so that in case anything goes wrong, the system admin doesn't have to come back to the developer. He can just quickly move back and take the last stable version and make sure that no one, the customers do not have to face a problem. But either ways, if there is some, once the code is in version control, the developers can then build it. At this point, if there is some kind of error or some kind of problem pops up, they can immediately use that feedback and rectify it right there instead of waiting till the release. Similarly, if it works, it then goes into unit testing, then it goes into the quality assurance testing, and then automated testing. Again, at any point in this phases, if anything breaks or if one of the testers finds some flaw or some error, they can send it back directly without having to waste time. If all of this is fine, then it can then go into production. But even here, even at this point, if something breaks, something is not getting deployed, or after deploying it crashes, something happens, they can immediately first roll back using version control and then send it back to the developers so that they can fix it quickly. And if everything works, then obviously they can keep looking and measuring and validating what worked, if anything failed, what failed, and then use that feedback for future releases. So this at its core is what DevOps tries to simulate within your organization. So now that you got an overall gist of the core philosophy of DevOps, let's quickly look why DevOps really matters. So in the beginning, I spent some time saying that software is eating the world, but in reality, it is DevOps which is eating the world. This is because of DevOps and maybe not specifically just DevOps, but other practices like Agile and all, which have completely revolutionized the way software is being developed, and which is why we have managed to get so much software in such short time. So if you think the amount of time it would take for software to release in 2010, forget the amount of time. Just if you can try to recollect how many softwares would you see getting launched or being announced in 2010, there would hardly be maybe one or two a month. But right now in 2020, on any given day, on an average, you would see 10 good softwares being released. And all of this is possible only because DevOps makes it really speedy for you to release software. And I'll talk a little more about how this is achieved. But thanks to DevOps, creating new software has become easier and really, really faster. And just compare this to the age-old enterprises which use the waterfall approach. So for any single software to come out, it would take anywhere between 2 years or 3 years. But now with DevOps, you have startups which are releasing new software, releasing updates to software almost every day. So the release cycle specifically has reduced from the waterfall approach, which used to take 2 to 3 years, to somewhere between 10 to 14 days now. So, and that itself is like a huge reduction in time. And at the same time, you probably have also noticed softwares look much better now compared to 2010. They are easier to interact with. They have a better user experience. They have a better user interface. Obviously, there has been a lot of work which has gone into those individual domains as well. But DevOps has kind of accelerated that as well. And lastly, if you have noticed, the cost factor has reduced significantly. So in 2010, if there was a company creating a software, they would probably be talking thousands of dollars. But now you can just use a license for a software, which will probably cost you maybe double-digit dollars if it's a really expensive software. So all of this has been possible all thanks to DevOps. The other thing that DevOps has really changed is the presence and the global outreach. So initially, back in 2010, again, you had American companies creating software for America, and you had Indian companies creating software for India. Eventually, they started realizing it's expensive for them to create software or pay software developers in America. So which is why a lot of this software requirements started getting outsourced or shored off over to India. And this is constantly changing and evolving. But with DevOps, you have people building software in India, which is now being used globally. So for example, good use cases or good examples of this is Freshworks, Postman, which are being built based out of India, but are catering to developers and users globally. Finally, we have a lot of software democratization that is happening. Back in the days, if you wanted to build an application, you had to do everything from scratch. But now, thanks to a lot of advances in open source and a lot of community initiatives specifically, you don't have to do anything from scratch anymore. You can just get started, and you probably have half of your work done already. Because think about a lot of companies like Google, Facebook, which are open sourcing the libraries that they use. In fact, even a lot of the libraries that they themselves use on their products are being open sourced. So you can use those libraries in your product, and you can just build over that. So that kind of saves a lot of time for you as a developer, and it also gives you a quality product which compares to something that a Facebook or a Google has also been building. So these are some of those intangible aspects that a lot of people see in DevOps, and how it's really kind of adding value for companies. But let's see what are the kind of benefits when it comes to cash. Thinking about money specifically, the Gartner currently predicts that the DevOps market by the year 2023 is going to be worth 9.40 billion US dollars. That's a lot, which means there will be a lot of opportunities for both companies which sell DevOps tools, as well as developers who are into the DevOps practice. And the reason why this is happening is because it's becoming more and more evident that it's cheaper to fix defects in the development stage itself, rather than first releasing it into production and then coming back all the way to ground zero and then again fixing it from scratch. So while this sounds obvious, it's interesting to note that it's actually 30 times cheaper to fix defects in the development stage. So this is something that really excites companies. And if you tell a company that DevOps can help you save your cost, which is 30 times, they are game. So this is where companies are benefiting and large organizations are benefiting from DevOps. But specifically coming to you as a developer, how is DevOps going to help you? So a survey by for upskilling in 2020 showed that the DevOps journey is still a huge challenge for more than 50% of developers. And this is a survey specifically made in India. The other part of the survey also says that there is an enterprise adoption of DevOps practices has risen to 24%. Now, this is the only point that I really want to stress on. Enterprises and large companies, and even small and medium scale companies and startups, are actively moving their engineering processes to DevOps practices. And what this means is they are going to require more DevOps engineers, as they call them. But more than 50% still are finding it a challenge to even take that up, which means this is more of a demand and supply problem. There is a huge market with a lot of job opportunities for developers who are able to do it, but very few currently have it. So if you are looking at enhancing your career or looking at how you can make your career grow faster, DevOps is something that you definitely should be looking at. So, and also DevOps engineering is the most popular title for recruiting in India. Again, not politically correct, but still we'll just let it slide. Now, this is like, if what I said so far isn't convincing enough, then let me share a survey from Stack Overflow, which talks about the median salary for a DevOps engineer in India and US. Let's just look at India. So I do not want you looking at the numbers here. I know the numbers. Oh, and by the way, these are numbers for a beginner, a fresher, with probably a 0 to 1 year experience in DevOps. So I know the number is $15,000, which is, I think, close to 11 lakhs per annum. But what I really want you to look at is DevOps engineers get higher median salary compared to data scientists even. And if you remember, data scientists were like one of the most hottest profession of 2019, and everyone was like, if you want a higher salary or you want a better package, data scientist is the way to go. But this graph by Stack Overflow shows something completely different. So something just to keep in mind. Again, do not really focus on the numbers, but here are some more numbers just to tempt you a little more. These are some of the starting salaries that that a lot of companies in India are providing to freshers. Again, this is a salary details of just freshers. If you are experienced, you would probably be making way more than this. So I hope this was some useful data just to, if you need to make decisions. Okay, so now that you know what DevOps is and what is the demand that DevOps has in the market, let's really dive into the core of DevOps and see what is the philosophy that and how do you implement DevOps in a company. So at its core, DevOps is comprised of 4 important things. The first one of this, and these 4 important things together are called as the CAMS formula, which was put together by John Willis. So the first piece of this puzzle is the C, which stands for culture. Now, like I was mentioning in the beginning, this whole change and the shift in thought process came because there was this constant infighting happening between the developer team and the operations team. But with DevOps in picture, what everyone wants to focus at is making everyone as an equal. Your software development team and your operations team is equally important. And more importantly, there has to be a bonding between them, which is only possible through creating that culture which wasn't there. So like I said in the beginning, you would usually find your software developer team sitting right in the center of the office, occupying all the posh locations, whereas your system administration team would be somewhere in some corner. So this is the first change that DevOps advocates for. Creating that culture of equality wherein everyone has equal say in everything that is being done. So it could be an operations guy telling a developer to change something in his code and the developer openly accepting that. So that cultural shift is the core of what this entire philosophy is. So DevOps firmly believes that people are more important than the processes or the tools that are being used within the organization. So it is always the people that matter the most, not the processes, not the tools. If you have the mindset right, your processes will anyway fall in place. And if you have the right processes, it's very easy to pick up the right tools to use and get things done. The next important thing is automation. Now, here is with DevOps, there has been always this cultural thing wherein they want to automate as much as possible. So we all know as human beings, we tend to make mistakes. Sometimes you can see there is an error right in front of you and you can't see it because it's a human tendency to overlook things. But that's not the case with automation, which is why DevOps strongly advocates for having everything automated, be it right from your code deployment, your code building, or even creating that infrastructure for your code to be deployed. Not to forget the testing part, which is the most crucial piece in this entire puzzle. Everything needs to be seamlessly automated so that there is minimal human intervention and which would then result in minimal errors. Now, one important thing that you probably are thinking here at this point is, if everything gets automated, how does it affect my job? I really want to clarify here, automation has never and will never take away anyone's job. Yes, there will be certain things which get redundant, but you would not be jobless because of a computer or a robot. Because automation at the end of the day is still a computer program and it needs someone to run it. And if you upgrade yourself quick enough and if you can keep up with the industry itself, then there is no way a computer program can make you redundant. So always keep this in mind. I hear a lot of people asking me, is automation going to kill our jobs? Is automation going to take away our jobs? It's not. The next important piece is the measurement. Everything that happens in DevOps is strictly measured. It could be even the amount of time taken for a release. It could be the amount of time taken for deployment. It could be the scale at which it was deployed. It could be the number of hits before the server crashed. Everything needs to be needs to be measured. And this is something that literally becomes the feedback loop and improves the entire process over time. And finally, sharing. Knowledge sharing is something that DevOps strongly advocates for. Now, this could be knowledge within teams, it could be within external teams, so long as there is a positive flow of knowledge. For example, someone from the engineering team knows something and would love to share it with the operations team or vice versa, or anyway. Or it could be within your team, right? For example, take for example, JavaScript libraries. Back in the day, JavaScript was the only library, and now you have hundreds of various libraries which keep coming up almost every day, and it's difficult to keep track. So if your colleague has heard of some new library and would like to share details about it, then this really facilitates it. And in the old days, you could do it over water cooler and over lunch, but now it's getting slightly tricky with this whole virtual environment, but still the concept still remains. So now let's see how you can implement DevOps. So we'll talk about the 3 pillars that form the core of DevOps. So the first one, no guesses, is obviously automating everything. And infrastructure automation is the first thing that is key to implementing a DevOps strategy. The second is continuously delivering so that at any given point in time, your customers are not left with a blank page or say a status which says that web page not found or the server is down or something like that. And finally, reliability engineering to make sure that there are people continuously evolving the product and making sure that the product has the highest level of standards that it requires. So we are going to look at each of these individual pillars and see how they together make up DevOps. So let's start with infrastructure automation. So like I was saying in the beginning, the core of DevOps is to make sure that everything is automated, right from your code, right from your deployments, your infrastructure management, everything needs to be automated. So infrastructure provisioning is one of the key things that is one of the major reasons why you have a lot of issues. So for example, you could be running a Linux server in the cloud and your developer could be creating an application on Windows. And then when you actually go to deploy it, you realize it's not working. So making sure that your infrastructure is being provisioned in the right way is very important, and DevOps kind of helps you to automate that entire process to remove any existing errors or any potential errors. And this becomes even more crucial, especially when you're using cloud services. So with cloud services, you do not really need to provision in advance. You can provision the required space or the bandwidth as and when required. So DevOps and the tools within DevOps kind of help you automate this entire process. The next is automating application deployment. This is another common problem wherein you see a lot of problems cropping up. For example, same thing, like the developer has built it using Windows, and the operations team is using Linux servers to deploy it, and then suddenly you see that it's not working. Or maybe the Docker containers or any kind of deployment has failed. So the moment you automate all of these processes, that entire flow is taken care, and you as a developer do not have to worry about all of these things. Finally, runtime orchestration. So for example, your application is using a couple of third-party libraries, and your operations team forgot to initialize or make sure that those libraries are present in the infrastructure. So simple errors like this can make your application crash for no reason, even though the application is perfect. So using tools like a couple of tools, you can automate this entire orchestration and make sure that this moves seamlessly. Next, coming to continuous delivery, making sure that your customers can always access your application or your software at any given time. So you surely have heard this saying called as always keep shipping, and that is the core of continuous delivery. So for continuous delivery, you have three major aspects. One is making sure there is continuous integrations, which means your builds should pass the what we call the coffee test. So the amount of time it takes for your build to get ready should be lesser than the amount of time it takes for you to get coffee. Now, if I don't think anyone here takes longer than 10 minutes to get coffee, right? So your build should also take that much time. And to do that, you need to commit small bits. So this adds another advantage wherein if there is an error that you find out, you can discard just that small piece instead of rather having to then comb through the entire piece of code that you last committed. You could just specifically point, okay, this didn't work. I just need to check this particular step. And lastly, you need to continuously keep returning the status, logs, and artifacts. What worked, what didn't work, what is the stable version available. The next is deployment, wherein you're continuously deploying. You need to create immutable artifacts, which once deployed cannot be changed manually. So once it's out there, no human can interfere with it. And one more very important thing that a lot of people don't do is deploy to staging. It's always important to first deploy to staging to make sure that everything is working. And also, if anything breaks, you can quickly come back and save everything without having to cause major errors. Finally, delivery, wherein you finally get into production. Always test for cross browsers. This is one of the biggest problems that we face. You will see a lot of applications working perfectly fine in Google Chrome, but the moment you open Firefox and it suddenly isn't working. And the reverse is also true. You will find people saying that this application works only in Internet Explorer. Yes, because there are people who unfortunately still use Internet Explorer. So just for the sake of this, people, let's try to create automated tests which check for cross-browser, how your application performs across all browsers. Also make sure to check performance, and more importantly, make sure to check security, because using your application, a lot of people are sharing sensitive data, which you as a developer may not care about, but they do care about that sensitive data. And this data shouldn't fall in the wrong hands or shouldn't get exposed unnecessarily. So make sure that all of this is taken care. Always keep testing, create unit tests, integration tests, and this is something that your quality assurance team will usually take care of. But also, if possible, add a test-driven testing strategy which keeps testing continuously. I know we are slightly over time. I'll wrap it up quickly. Don't worry, I'm not going to keep you all waiting for too long. Coming to the last pillar, which is reliability engineering. Here, what we talk about is designing for operation. Think about the users. Now, we know many a times, unfortunately, we have users who act really stupid and would do things that we as developers thought they wouldn't even think about. But you really need to think that through and make sure that you create systems which are resilient, which will even handle both your stupid user as well as your very smart user. So both of them have an uniform experience. The next is having a culture of responsibility. A lot of times, instead of just the developers assigning blames to operations team or the operations team saying that the developers messed up, each one needs to own up for their own mess. And that's the only way you can improve. And more importantly, needing to build, measure, learn, and repeat. This is, again, one of the core that I had mentioned in the beginning. Keep building, keep measuring, and based on the feedback that you get, keep learning from it, and then keep repeating this entire process. So to quickly sum it up, these were the three pillars of DevOps that we talked about. You have automating your entire infrastructure, making sure that your applications are delivered continuously, and making sure that your engineering and your software is reliable. So now that we saw what it takes to get into the DevOps mindset, let's see how this can be actually achieved in real world. Now, the good part about this is, luckily for us, there are hundreds of tools that you can use. And now I'm going to talk about some of the most commonly used tools that can really help you at each of the stages. Again, none of these tools are a personal recommendation. These are just the popular tools that I picked up. I'll be also talking about all the tools shortly. So in your planning stage, you probably are already, I'm sure almost every developer here is already using Jira. There is also Trello and Basecamp if you need. Once you get into your coding, you have Git, your GitHub, Bitbucket to maintain your code, commit, all of those things. Once you need to create a build, you have Maven, JFrog, or Habitat for that. If you need to test, create tests, you have Cucumber, Selenium. If you are working on mobile applications, you have APM. To release, you have Jenkins, CircleCI, and TeamCity. Obviously, Jenkins is by far the most default one. And finally, to deploy and operate, you have your major tools like Kubernetes, Docker. You have AWS, which takes care of the entire lifecycle. And then you have tools like Chef, Ansible, which manage all of this individual services. And finally, you have, for monitoring, you have Nagios, Datadog, and Splunk. Now, the interesting part about these tools is many of these are actually free and open source. Some of them obviously are paid and depend on the type of license that you take. So this is one major good thing, that a positive thing that you find in the DevOps ecosystem. But let's not limit to these tools. Here is a periodic table which has all the tools which constitute in the DevOps ecosystem, put together by digital.ai. I will share this after the presentation if anyone is interested. So it has all the tools which can be used, all ranked as well as categorized based on the type of action that they do. So you have tools for analytics, you have tools for integration, you have tools for security, you have tools for management, you have tools for containers, everything grouped and classified. It's beautiful to just look at. Sometimes I just keep looking at this. So yes. So in summary, now that I can see that we are already way ahead of time, and I feel it's time to wrap up. To quickly summarize what we talked about today, DevOps is, in a way, getting together the developer and the operations team. Maybe not politically correct, but you are still somewhere close. But in reality, it's the philosophy of integrating software development and IT operations. to make sure that you provide quality software. I know a lot of people have insinuations about what is DevOps and what is not DevOps. So here is a couple of things. So DevOps is a mindset and a holistic approach. It's not something that you can just copy from me and say that I'm also doing DevOps. It's not how it works. It's not an individual tool or an individual method. It's a collection of processes and tools like I just showed you in the previous slide. More importantly, it's a community-driven effort, which is why you see a lot of these initiatives coming from within the community. In fact, a lot of these tools have come out from the community itself. And finally, it's a strategy driven by learning and experimentation. So at no given point in time can you say that, yes, you have nailed your DevOps strategy. You need to keep fine-tuning it always. And eventually you will reach a point wherein you actually get it right. So to wrap it up, DevOps is about communicating, automating, and collaborating with your teams. Thank you so much for listening to me. I hope this was useful. I hope I managed to add some perspective and some thoughts to DevOps. And I hope there is something that you will take away from this. I'm open to questions. Any questions, feel free. I do not see any questions at the moment, but yeah, happy to take any questions. You can ask me anything about DevOps, about literally anything under the sun. If you want to get one-on-one with me, here are my social coordinates. Happy to help in whatever way I can.
It was indeed a great session, Jonathan. Thank you so much for taking time out of your schedule. Actually, I know you're very busy, but still you took time. Okay, so guys, we are open for questions. You can put your questions in the question section. Apart from that, I've shared all the social handles also. Like for future updates, you can for sure go ahead and click on the link and you can follow us there so that you can get to know what are the other sessions we're planning to do. I have shared a DevOps community link also. It's a WhatsApp group when we can keep on updating the things which is going on, or if you have any doubt, you can always ping there, and if anyone know the answer, they can tell you there. Apart from that, I've shared a feedback link. It would be really great if you can provide us a feedback on the session. Please do so so that if you have any topic recommendation also for the future webinar, we can take that forward as well. Okay, so yeah, I think we are having one.
Yeah, also quickly to add there, if there is something you need to add about me, like if you need to say bad things about me, feel free to add it in the feedback form as well. Happy to hear bad comments about me and my session.
I don't think so there would be any. Even I enjoyed. I was like keep on listening to you, and I got to know a lot. So if I can understand, I think a lot of people can understand that. So I don't think so there would be like me coming from a non-tech background. So yeah, that is it.
All right.
Okay, so there is one question from Gopal.
Yeah.
How to grow a career in DevOps? Where to start? And it's been upvoted twice. Okay.
Okay. So I think so. There are two things that you can do. One is completely start from scratch, which means you either pick up a particular space that you want to be in. Maybe you just want to improve your entire coding side of DevOps, or you want to improve the operation side of DevOps, and then pick up courses or pick up tools. And all of these individual tools have their own courses, by the way. So it's really easy to learn. So if you go back to the slide, which has all the tools, this or even this one, all of these tools have, I think most of them have individual courses on their websites, which will teach you to learn everything that you need to know about that particular tool, as well as the general DevOps ecosystem as well. But the easier way to do this would be So eventually you're going to be working on something like, say, an Amazon, AWS, or maybe Azure or Google Cloud Platform, right? Now, most of this AWS, for example, has its own set of tools which take care of pretty much this entire uh, pipeline itself. Now, you could just go to AWS, and AWS has certifications and they have courses at least which teach you all of this. Now, if you want to get certified, you can go ahead and do that, but at least you'll get the basic knowledge. The only caution that I would want to put is you won't see a lot of companies which use all the tools that AWS has, because they do not want that kind of tie-in or that kind of push to wall happening, so that they are more open to experiment with any other tool. So, but overall, you will get that overall understanding of what each tool does, and then you can just replicate it using a different tool altogether. So either of those two approaches is something that you can try.
I hope you got the answer, Gopal. And apart from that, just to add it up, like if you need to start on Kubernetes at least, Kubernetes, or you need a basic knowledge on the Kubernetes and Docker, we did a session on Kubernetes, and you can refer that. I might be uploading that session maybe by today or tomorrow. So for sure, you can go to our YouTube channel and you can have a reference from that. Okay, so I'm moving it to answer. Do you guys have any other question? I think you guys are like, it's already time, just leave us.
Tired?
Maybe.
Bored? Which is it?
Okay, we'll wait for like 5 more minutes. If you have any, not five, yeah, 2, 3 more minutes. If you have any questions, you can shoot. And please give your feedback. It is going to be really helpful for us. And to add it up here, like until you guys shoot a question or something, the next session is going to be the continuation of our last webinar that was on Node.js design pattern. That was on the beginner level, and the next one will be on the intermediate level. So that video, that recording also will be up by tomorrow, majorly. So you can, if you want to attend the session, just go through the recording as well, so that your base is clear and it would be good knowledge for you. Like if you have, so now please share the link of Docker and Kubernetes. Yeah, I'll do that, Abdul. Like maybe by today, by tonight, I will be uploading that so that you can have the access.
Sana, is there some way I can add a file here? I just wanted to share the periodic table.
You cannot add a file. The thing is, Jayashree, just join the group, the DevOps group. I will send the whole deck in the group. Like after the session, we can do that. So if you can join that, because there might be some editing needed there. So once we do that, we can share that. Okay, there is a question from Chintan. How much of coding knowledge is required?
So again, it depends on which part of the funnel you want to be at. So for example, if take for example, you want to just take care of the deployment side, you just want to configure servers and all of this. Now, most thanks to things like AWS, Azure and all, they have made the entire process of creating servers like literally seamless. So you don't need to know code. And then you have tools like Chef, Ansible, which make it even simpler. And again, you don't need to know code. But if you want to, so if you want to be at that end of the segment, then you don't need to know much code. But yes, you need to have the understanding of what's happening in the code. You might not need to actively code, but having that understanding of what the code is doing will help you a long way anywhere. But if you want to be in the beginning part, say you are in the coding or where you are testing, here it's highly recommended that you know to code. And I'm sure the next follow-up question would be, is there some particular language or any particular domain that I should be looking at. Again, it's really open. You can be a master in one, so long as you get the concepts clear. You can literally take care of all the rest. But from a personal experience, I have found that Python and Java help a lot. So again, that's a very personal opinion, but either ways, others work well as well. Any other questions? Hey, I have to put up and ask me anything. You can ask me anything. Like, feel free to even ask me embarrassing questions. Except my salary. Don't ask me my salary because that embarrasses me.
Oh my God.
Other than that, you can ask me anything. Right?
And if anyone from your current company not listening to that. Okay, Jashi, I'll share the group link so you guys can join the group. Also, please provide the feedback. I keep on saying that. Please provide the feedback. Okay, I think we are done with the questions. You guys are not asking anyway. If you came across any question after the session, you can for sure ask in the group. I think Jonathan also will be joining that, so he can answer there. Okay, so I think we should wrap it up. I'll not take much time from your Saturday. Guys, enjoy your Saturday, enjoy your weekend. Thank you so much for joining in, and thank you so much, Jonathan, for such a valuable learning session. I personally really enjoyed, and I was just seeing the feedback also, and people also enjoyed a lot. Thank you so much, guys. Please give the feedback. It really means a lot, and thank you so much, Jonathan. Thank you. Bye bye.
Bye.